Sorry that last video cut off so abruptly. I went back to my camera and said that my card was full. So I had to go delete some videos, yada yada. All right, so let's look at this. We were just talking about how to name a vector and to write it in its component form. So here we have a vector. It starts at J, goes to K. So we would write it like this, JK. And no, I'm not kidding. That's really how you would write that. And you would call that vector JK. All right, and so writing it in its component form, we have 1, 2, 3 units going in a horizontal direction. So that would be my X. And then 1, 2, 3, 4 units over here, which goes upside down, which would be my Y. So in component form, it is going to look like this. Well, that was exciting. Okay. A transformation is something that Optimus Prime does. Ha 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 ha, yeah, okay. It's not that funny. Sort of, yes. He does. He transforms from a truck into that. How? I don't know. It doesn't seem like physics can explain that. But transformations that we're going to talk about aren't exactly the same thing. Okay, so a transformation, this is some vocabulary words for you. A transformation for real, not pretend, is a function that moves or changes a figure in some way to produce a new figure called an image. Now that does sound like going from a truck into, Optimus Prime, but it's not quite the same thing. You'll see. Okay, another name for the original figure is the pre-image. So you take the pre-image, you do something to it, and it changes into the new image. Okay, the points on the pre-image are the inputs for the transformation. So it's like your X values. And then you put it into your function machine or whatever, and what comes out, the output, and the points in the image are the outputs. So you get the outputs, you redo the image, and then you take your pre-image into your image. Okay. A translation moves every point of a figure the same distance in the same direction. Okay, so you're just taking, it would be like if I took my calculator right here, and it was like this on a coordinate plane, and I just moved it to here. That's all. It's exactly the same thing, it's just moved. So one thing that I want to point out, okay, a translation moves every point of a figure the same distance in the same direction. It maps or moves the points. So you'll see the word maps quite a bit too. One thing for you to notice is that the original, in this case it's a line segment, the original line segment has point P and point Q and their original coordinates. And once they're mapped, they become P prime. Kind of funny that I was talking about Optimus Prime, right? But P prime is the image of P, and Q prime is the image of Q. And in case you can't see that, when you do a prime, you have a little line right there. Okay, so a couple things to look at when we have mapped something. The line P prime, okay, the length P to P prime is the same as the length of Q prime. Okay, so the length from here to here is the same as the length from here to here. Another thing that you need to notice, and we didn't go over that this year, I don't know if you've talked about this in years past, but when you have two lines like this and they've got little arrows like this, it means that they're parallel. Okay, so this shows that not only are we going the same distance, but we're going in the same directions. We're not like going out like that. So P prime is equal to Q prime, and the segment P prime written like that is parallel, okay, to Q prime. I know that's a lot, it looks like a mess, but that's just saying that this line right here is parallel to that line right there. All right. So looking at this again, okay, one thing that I want to show you is that translations map lines to parallel lines and segments to parallel segments, okay? So this is a line segment, and it translated to another segment. So if this were a line, this would be going through like this. And even though this is traveling the same distance, they're not translations of each other. Okay, this is not translating to this because this is a line and this is a line segment. So that's one of the things they wanted to point out. Okay, so translating a figure using a vector. So we're going to be given a shape, and we're told how far they want it and what direction that they want it to move, and that's what we're going to do. We're going to move it. Okay, so first of all, this is where you're going to want your graph paper. A is 0, 3, so there's A. B is 2, 4, so 2, 4 is right here, this is B. And C is 1, 0. Okay, so we've got this nice triangle right here. And they want us to translate triangle ABC using the vector 5, negative 1. So what does that mean, 5, negative 1? Well, this means that this is going to be moved 5 units to the right because it's going in a positive direction. So 5 units to the right, and 1 unit, which way? It's negative, so it's going to be going to the left. So 1 unit, 1 unit down. What am I saying? It's negative 1, it's going down 1 unit because this is the Y part. I apologize. Okay, so 5 units to the right, 1 unit down. So let's do that with each one of our points. So point A, 1, 2, 3, 4, 5, and 1 down. So that is now point A prime. B is 1, 2, 3, 4, 5, and 1 down. So there's B prime. And C prime, 1, 2, 3, 4, 5, 1 down, is right there. So I took that exact shape and I moved it to the right 5 and down 1, just like that told me to. Okay, we will move on with more in the next video.